Good afternoon. We're going to be looking at water today. I'm going to mention why it's essential for our health and well-being, why it's particularly good for us, how it can be particularly bad for us, what UK legislation says, how the well standard compares to the UK legislation, and then a little bit at the end on tenants and landlords' responsibilities and how that can confuse matters a little bit. So, water. It's essential to health. It has some obvious benefits, like it quenches your thirst. If you get thirsty, it cools you down if you're hot. There are some less obvious benefits. It maintains good chemical balance within the body. It provides oxygen to organs. It lubricates bones and joints, and it balances the electrolytes, vitamins, and minerals in your body. If you have a chemical imbalance, that can cause irregular heartbeat, convulsions, and a general run-down feeling. So it's essential for chemical balance. It flushes out toxins as well, primarily through sweat and respiration and urine. It promotes good kidney function if you've got plenty of water going through. And it also breaks down and dilutes salts and minerals, therefore it reduces the likelihood of kidney stones. It also improves your mood. Even if you're mildly dehydrated, it can negatively affect mood and ability to think. So we supply the BMF staff with a lot of water during the day to keep them happy. It helps digestion. It improves the function of the gastrointestinal tract. It boosts metabolism and helps the body properly break down food. It also helps prevent constipation, because if you're dehydrated, the body needs to get water from somewhere, and it can take it from the large intestine, which dries everything else out inside. Water can aid weight loss. If you drink water before a meal, it fills the stomach a little bit and it suppresses the appetite. It also increases the rate you break down fats in your body. And if you drink water instead of your high-calorie drinks, like sugary fizzy drinks or alcohol or tea or coffee with sugar in it, water is basically calorie-free, so it's not fattening at all. Water also treats headaches and migraines, which are generally caused by dehydration. It promotes a healthy skin. It improves the capillary flow and moisturises the skin, which gives you a healthier, younger-looking skin. It also relieves hangovers. This is a subject I've researched quite extensively. Alcohol is a diuretic, and so it dries you out, and a hangover is basically you're dehydrated. So if you drink a lot of water before going to bed, you generally avoid a hangover. So one of the major benefits there. But it can also be a health hazard. We've got 1 billion people without access to safe drinking water worldwide, and 2 million annual deaths attributable to unsafe water, sanitation and hygiene. And there are various types of pollution. Mineral, which is your metals, lead, zinc, mercury. Microbiological, is your bacteria in the water. You can get chemical pollution through agriculture, usually herbicides, pesticides. And you can get others like radioactive pollution. And the effects of this are varied. You can have some people can show no symptoms at all. Some people get immediate symptoms like nausea, vomiting, cramps, and diarrhea are fairly immediate effects or symptoms. But the more long-term diseases and more serious problems build up over time, and you get some cancers like leukemia can come from a long-term exposure to polluted water, as can infertility and even some developmental problems such as learning disabilities through long-term exposure to polluted water. And there are many factors that affect how each person is affected by pollution. The age and general health of the person, the type of contaminant they're exposed to, the amount they're exposed to, and how long they're exposed to it. Now I've put up here many pollutants are unlikely to be introduced from within a property. This is usually groundwater. It's water before the water treatment, before it comes into the buildings. Once water is inside the buildings and contained within pipes and tanks, there's not so much that can happen to it. It's unlikely to get mercury in it somehow like that. But the water can deteriorate. Quality of water can deteriorate in a building once it's in. Through various reasons. One is stagnation. If you've got too much stored water, the water can stagnate. Or if you've got dead legs of pipework full of water, water can stagnate in those. Or infrequently used outlets, the water's not moving through the pipes. You can get unclean conditions, tanks that haven't been cleaned. You get the sediment inside the tank can produce nutrient for bacteria to grow. As can unsealed tanks. You may have tanks where the lids aren't fitted properly, or you haven't got screens on your overflows, and so you get rodents and their waste maybe dropping into the tank. You get spiders and insects falling in. You might even get mice and pigeons and things in your tank, and all these will affect the bacteria in the water. And you can also get other contamination from tap fittings. People washing their hands in toilets, they can contaminate the taps like that. So, but all these contaminants are largely microbiological once the water's in the building. So what happens about this water? How can we make it safe? And the answer is it is treated before it's allowed to be delivered. Now the water in the UK and the whole of Europe actually has to comply with the EU Drinking Water Directive. And this is currently we have to comply with this. It's a EU-wide directive, and each member state has to have their own legislation that, as a minimum, complies with the EU guidance. And in the UK, we have got these two main regulations: the water supply, water quality regs, and the private water supplies. This is for water that's coming up through another way, maybe from a borehole or a well in your own property. But either way, you have to comply with these, and the UK not only complies with the EU, it's got more strict limits, and it's got some additional limits as well. And this makes the UK drinking water some of the best in the world. And we really can rely on it being a good quality. And it's governed by extensive testing. So the water in the UK that comes to the door is pretty good quality. It's not the same in all countries. Even in Europe, how many countries do you go to on holiday where they advise you to boil the water before you drink it? It's certainly not the case worldwide. And even in America, the Environmental Protection Agency warned that threats to drinking water are increasing, and we can no longer take our drinking water for granted. And so we're very lucky in the UK, but it's not the same everywhere. Now, because of that, the well standard has got an interesting approach to it. It requires a broad initial assessment to evaluate the building's water source. So what happens is when the water comes in the building, we do an extensive test on that water to see what quality it is and what pollutants are in it. And as you can't actually control that very much, from then on, once you know what's coming in the water, you can then, within the building, put various filters in place to extract the contaminants that you find to be in the water. And then you can go through various enhancements. You can continue to do some regular monitoring, which is very wise, because just doing a one-off test may not be representative. So you can do some periodic testing after that. So the initial fundamental water quality is part of this test. You have to look at the sediment in the water and the microorganisms in the water. And the term used to measure sediment is turbidity, and it just means how cloudy the water is, turbidity. And you can measure that by shining a light through it and see how much the water scatters the light beam. And the reason this is important is because, well, sediment's bad news generally, because if you've got lots of clay or silt in the water, it's going to fill up reservoirs quicker, it's going to fill up lakes quicker. And it's also not great for aquatic life to have water that's full of too much sediment. And it's not just sediment, it is clay, silt, organic and inorganic matter in there, plankton, other microorganisms. Lots of things can be in the water. But the reason Well is interested in is the sediment also acts as a way of transporting metals and bacteria. So it's something for the pollutants to fix onto and be transported in the water. So if you've got very little sediment, there's less chance of there being pollutants in there as well. And the other thing we want to measure for the general fundamental water quality is microorganisms, and in particular the coliforms and E. coli. Now coliforms are mostly produced by the inside the gut of warm-blooded mammals, but not always. Some of them are produced by plants and in the soil. And actually, a lot of them are not harmful at all. What are harmful are pathogens, which are bacteria that can cause, or bacteria or viruses or other microorganisms, which can cause disease. That's what you're trying to avoid being in the water. But there are a lot of pathogens, and they're actually they're in quite small amounts in the water. But they behave in a very similar way, and they come from the same source mostly as coliforms, and we can measure coliforms quite easily. So, and they also react in the same way as coliforms and pathogens react in the same way to water treatment, etc. So, they're it is reasonable to relate number of coliforms to the number of pathogens. So it's quite a good test for water quality, or bacterial quality. Now the reason I'm interested in E. coli as well, there are some coliforms, as I said, produced by plants and soil. It's the fecal coliforms, the ones you really want to find, but even some of the fecal coliforms will continue to breed outside the warm-blooded animal's gut. So in fact they can continue to multiply outside. E. coli is the one that can't. So E. coli is the one coliform that will only breed inside the mammal gut, and so that's the best indicator of whether there's any fecal contamination in the water. So that's why those are the two important tests for the fundamental water quality. Beyond that, we're looking for other contaminants, inorganic contaminants like metals, the organic ones, which come in the water, agricultural contaminants, which are usually herbicides, pesticides and fertilisers. And also the water treatment companies put in disinfectants. They sometimes put in chlorine to disinfect the water, they sometimes put in fluoride to keep people's teeth strong. So there are some water additives to be put in which you want to measure as well. So all these things have to be encompassed in this main big water sample you take right at the beginning. And this is, most of it is a little bit on the second page. So what I've got up here is the actual elements we're looking for, the well limit, the water standard water quality regulations for the UK, and also our UK laboratories level of detection. And you'll see a couple of interesting things here. We've got the ones in red are where the well standard is even more stringent than the UK standard. So we've got the turbidity, that's one they're particularly interested in, is much a tighter limit than our normal ones. Copper is a little bit higher, a little bit lower, the limit. The agricultural contaminants is slightly different here. We measure in this country total pesticides rather than break them down a bit, which we might have to start breaking them down more. But in fact, one of these is a slightly, yes, these two are a little bit tighter than the UK limit. And the styrene is an interesting one because the limit in well is actually smaller than our current level of detection. Our limit of detection is now 0.001 milligrams per litre, where they want 0.0005, and half of that. So we might have to talk to our UK labs about how we can do that. But, and the rest of them are fairly similar. So the fact that the UK standards are very high, it means that the well standard is equally high, which is good to know. There's a little bit more public water additives here. And again, one of them is slightly tighter than either of it. This is produced by the chlorine water treatment, a byproduct of the chlorine working. But it's still very close. So it's a good sign that the well standard is that tight. Now, one of the optimizations is to do some regular testing. Oh, there's one thing I was going to mention about this test. Retails at over £1,000, this test. And to get all the results in, there's 20 days turnaround time in it. So it's not a quick test, a lot to do, and it's expensive. I presume in the grand scheme of things, it's not one extra £1,500 or so isn't much, but in fact, for a water test, it's quite expensive. With that in mind, if you're going to do your regular testing, these are how many samples you've got to do in the locations you have to do. Just your fundamental water quality, which is your turbidity and your coliforms and total coliforms and E. coli. 10% of the total drinking water fixtures, 10% of the hand washing fixtures, and 10% of the showers and baths. You've got to take 3 turbidity samples in each, and then do an average of each of the 3 to get a result. And the microorganisms is as above, but it's only 1 sample per feature. So there's quite a lot of those to do. Sorry. If you look at the organic agricultural and drinking water taste, 10% of the total drinking water fixtures and 1 sample of each. And if you look at the additives, 10% of total drinking water fixtures, 10% of the showers and baths, 6 samples per feature, 3 free chlorine and 3 total chlorine. And again, you average the result. So there's quite a lot of testing to do, and bearing in mind some of that's quite expensive. Further optimizations, you can do this periodic water testing. You can, if you find anything nasty in the water, you've got to do something about removal it. So you've got to put usually active carbon filters in your drinking dispensers, and you can do these taste tests as well, and conduct regular maintenance of the dispensers. Quickly look at landlord and tenant. The normal protocol when you have a multi-tenanted, multi-let building is the landlord is responsible for delivering the water of wholesome quality to the threshold of the demised area. So anything that's a common water system, like tanks in the roof or hot water cylinders in the basement that serve the whole building, landlord's responsible for that. Tenant is responsible for water once it comes through their door. What they do with it within their demised area is up to them. And here's a schematic drawing where we have a simplified drawing, but we have mains water coming in here in blue, goes to a tank at the bottom, and most of the water, apart from a couple of little drinking water outlets here, most of the water is boosted up through the building to the tank at the top. Another tank up here, chlorifier up here, which is a hot water cylinder, and these all supply all the toilets in the landings, which are common area toilets, but they also go off and serve the tenants, individual tenants' areas. So the landlord is responsible for this tank, water in this tank, water in these risers, the tank up here, the hot water cylinder, all these areas until it gets to the threshold. And then the tenant's responsible after that. Now, in the Legionella guidance, the landlord does one risk assessment on this lot, and each of the individual tenants does a risk assessment on their own little bit, which is not a very joined up way of doing it. But the point I wanted to make here is if you have a tenant or someone fitting out one floor of this building and they're looking for the well standard, where are they going to do their water test from? Because if you do it here at this kitchen sink and you get a bad result, what are you going to do about that result? Where has the contamination come from? Is it this tank up here? Is it this tank down here? Or was it poor when it first came in the building? And no one will be able to answer that. So unless we do tests everywhere, and at £1,500 a test or whatever it's going to be, people might be reluctant to do it. So I think that needs to be discussed earlier in the project to work out whether you just take it from where it comes in, the building, and it's done. That's going to be the one test for everyone in the building. Or if the tenant's going to do, or each floor is going to have an individual test, how any dispute is going to get resolved. I haven't got an answer, I'm just pointing out there might be an issue there. I think that's me. Thank you for your time.
Thanks very much, Alistair. So, is there a question in the audience? Okay, yes? Let me come to you. There we go.
Yasmina Mikael of RES Long and Partners. I just wanted to ask about hormones and specifically estrogen in the water, whether that has a consideration, whether it's an urban myth, or if it's something worth thinking about or acting on. Because too much estrogen, although it's a natural hormone, too much of it, like anything, is no good. Thank you.
Not in the well standard, is the answer. It's a little bit outside my area of expertise. I believe it is an issue. There's an increasing amount of estrogen in the water supplies, but it should in theory be addressed by the incoming mains. But I think it is an issue. But I'm not familiar with the detail.
Sure, and presumably other chemicals like endocrine disruptors, phthalates and such like, come through on the VOC, which you've kind of touched upon today. So, okay, thank you very much. Let's move on to the next